Welcome to the Making Sense podcast. This is Sam Harris. Just a note to say that if you're hearing this, you are not currently on our subscriber feed and will only be hearing the first part of this conversation. In order to access full episodes of the Making Sense podcast, you'll need to subscribe at samharris.org. There you'll find our private RSS feed to add to your favorite podcatcher, along with other subscriber-only content. We don't run ads on the podcast, and therefore it's made possible entirely through the support of our subscribers. So if you enjoy what we're doing here, please consider becoming one. Well, there's a lot going on out in the world. I guess there always is, but in the last 24 hours it seemed especially so. As I'm recording this intro, we appear to be witnessing the complete implosion of FTX, the cryptocurrency trading firm, whose CEO, Sam Bankman-Fried, has been on this podcast, and he has been one of the most visible faces of the effective altruism movement. At the time I interviewed him, Sam was worth over $20 billion. It might have been $30 billion at the time, and had pledged to give virtually all of it away. Cryptocurrency is quite volatile, and as of, I think, the day before yesterday, he was worth something like $15 billion. Virtually all of which appears to have evaporated in the last 24 hours. It seems, along with the holdings of many other people who had their money and trust in FTX. At this point, it's not clear just what degree of malfeasance there was on Sam Bankman-Fried's part, so I will reserve judgment there. No doubt we will all learn more soon. But as to whether or not this is a bad outcome for him personally, for investors in FTX, and for the effective altruism community, there really can be no doubt of that. This was really bad news on all those fronts. In happier news, we had our first virtual retreat over at Waking Up. Over 40,000 people registered for that on the day. I think we had about 10,000 when Joseph Goldstein and I did a live Q&A at the end. Anyway, both the retreat and the Q&A are now available to be done at your leisure in the practice section in the app, and I think we'll be creating more of those in the future. Okay. Well, today I'm speaking with Neil deGrasse Tyson. Neil is an astrophysicist and the author of the #1 bestseller, Astrophysics for People in a Hurry, among other books. He is also the director of the Hayden Planetarium at the American Museum of Natural History in New York, where he has served since 1996. He has his own Emmy-nominated podcast, StarTalk, and its spin-off, StarTalk Sports Edition. The man has received 21 honorary doctorates and various other awards. He has an asteroid named after him. And most recently, he's the author of a new book titled Starry Messenger, Cosmic Perspectives on Civilization. And we focus on the new book. We talk about what makes science a unique human endeavor, the tension between respecting scientific consensus and overturning it, which leads to confusion about paradigm shifts and scientific controversies. We talk about the social importance of probability and statistics, climate change, our relative blindness to exponential cultural change, social media, social inequality and affirmative action, identity politics and a post-racial future, the wisdom of focusing on class rather than race, and other topics. It's always fun to talk to Neil. As you'll hear, he is always good company. And now I bring you Neil deGrasse Tyson. I am here with Neil deGrasse Tyson. Neil, thanks for coming back on the podcast.
Yeah, thanks for having me. I feel like an old-timer.
Well, you are a repeat and much beloved guest. And I'm pretty sure I've been living with you more than you've been living with me of late, because I digested your last book 100% as an audiobook. I tend to bounce between audio and hard copy when I really want to get something into my brain. But for you, I just happened to, there's some great fall weather where I am, and I took a bunch of long walks, and you were walking with me. It was really a miracle of technology and a wonderful use of time, which I highly recommend.
And it was I did narrate the book myself.
Yes, as you should, with that voice of yours. Have you narrated all your books, or have you?
No, just the shorter ones. I mean, I did a huge book on war. It was 600
Mhm.
pages or so. And I said, no, I can't. If I had the time, I would have, but I just couldn't justify it. Plus, you're taking money out of someone else's mouth where they read professionally, So I figured
Do you find it hard to do? Does it come easily for you, or
No, it
is
is,
it a
but not
difficult day at
600
work?
pages. To spend 6 days in a sound studio or whatever that would have taken. As it is, this book is relatively short. Story
Right.
Messengers, minus the endnotes, is 200 pages or so. And the book is a small format. So I could do that. Plus, a lot of it is in my voice, I mean, figuratively and literally, because
Yeah.
there's some storytelling that I do in there about events in my life and how that connects to the science and the culture and the geopolitics. So I felt that these are stories no one else can or really should be saying to you as you walk
Yeah.
walk in the fall weather.
Yeah. I find it hard to do, though. Actually, I find that occasionally I have written a sentence that I literally cannot get through out loud, and I have to change the wording it becomes a Cirque du Soleil routine for me to try to get to the end of the sentence, and I have to rewrite it for the audiobook.
Well, you're a brilliant writer, and I'm eternally envious, not in a vengeful way, but just envious.
Not in a dark way.
In a dark way, thank you. Your command of words that are just the right words in just the right time and place are brilliant. And what I try to do when I write is have the sentence work not only as words on a page, but as words that you hear in your head, so that there's a rhythm
Yeah.
and a flow and a balance of what words are used that may be a little challenging versus others that are not. And in that balance, I think it becomes an easier product to read out loud,
Yeah.
I should say.
Well, you do read it very well, so I recommend audio if that is a person's predilection. I should say the name of the book here. You said it quickly, but it's Starry Messenger: Cosmic Perspectives on Civilization, and the subtitle really does capture the angle here, because you do think about civilization a lot, and so we'll get into that. You've taken a turn slightly toward the political at various moments in the book, and I remember last time we spoke, your allergy to striking a political note was palpable and also understandable. Has something changed on that front for you, or what's your thinking now around politics?
The book basically came to term in the sense that it's been gestating within me my entire life, if I may use uterine analogies here. I remember when I was a middle schooler, early years when I'm thinking scientifically literate in a scientifically literate way, which began maybe when I was 9 or 10, but it didn't really sort of hit a stride until I was 12 and 13. And I just remembered looking around at full-grown human beings, adults, listening to what they're saying and watching what they're doing. And I say, what? You're saying what? You think what? And in one case explicitly, there was a comet headed around the sun, and it was expected to be very bright. Turned out that it didn't live up to expectations. But that's not what matters here. Astronomers had discovered a comet, and it was in all the news. No one saw it yet with the naked eye. It wasn't bright or close enough yet. And I'm walking out there, and there's a man with a placard marching up and down the street saying, "Repent, the comet is coming. The end of the world is near." And I said, "You're a grown-up, okay? Don't you have any understanding?" And so I've been collecting in me these observations of all the ways people in cultures and civilizations, and especially people in power, think about the world and how absent it is of science literacy, of numeracy, of especially statistical numeracy is lacking. And so it was in me, and I'm sitting there during COVID, and I said, it has to get birthed. This book has to come out, and it just got birthed whole. The whole thing just came out of me. I'm on this site,
Nice.
Goodreads, and someone asked, Dr. Tyson, when you were writing this book, how did you get through writer's block? There was no writer's block.
Yeah.
And so
that's great.
So it's been in me. I just haven't had the occasion to write about it. And in a way, it's my most scientific book, because everything about what we see, what we do, and what we think, I'm highlighting ways that a scientist would view that. And if you care, if you don't care, that's one thing. But if you wondered, what does a scientist say about what I'm doing? This is the book for that purpose.
What is it that you think makes science unique? If we're going to take a bird's eye view of our situation and distinguish science from the rest of human endeavors, how would you distill that for someone who's just considering this demarcation for the first time?
Yeah, there are two separable variables there. One is science as an enterprise, and the other is the scientist. And scientists, if I need to remind people, are also human, and they are susceptible to many of the sort of vagaries of what it is to be human. And so where you think your opinion is of higher value than someone else's opinion, you might think your opinion is a fact, even though the evidence doesn't support it. And all the portfolio of biases that you learn about, the great wiki pages on cognitive bias, the scientist has a susceptibility to it like everyone else. However, there's the expectation that they would try to ferret it out in some way or another. And so two scientists in an argument, there's an unwritten rule, that either I'm right and you're wrong, or you're right and I'm wrong, or we're both wrong. And I don't know many other arguments that unfold in society that have that prior arrangement in that conversation. And by the way, when you have conversations set up that way, at the end you say, I think we need more data, okay? Or let's wait until this other result comes in. It's, oh, great. Now let's go have a beer. So the arguments between scientists end up in a bar, and the arguments between other people, even if it's of a similar sort of intensity, can, in their limit, end up in all-out warfare, bloodshed, and death, because two people do not agree on their worldview of who they should worship, who they should sleep with, what side of a line in the sand you live on, what language you speak, what color your skin is. And in science, so much of it transcends that there's a limit to how much we're going to get riled over. And so there's great value to seeing the world scientifically, especially cosmically, because it lifts you up and away from so much of what divides us.
What are some common misunderstandings of what science is? It seems to me that we're living through a period where the dirty laundry of science, or the sausage making, pick your cliche, has been exposed to public scrutiny in a way that has left people pretty cynical about and frankly confused about science. I'm thinking specifically of our misadventures through COVID,
yeah, of
right?
Course,
So we have changing, and this is something that you touch on some. And we have these changes of policy which seem like frank confessions of scientific error that are marks against science as a methodology and science as a source of authority, whereas in most cases what you're seeing is just the kind of the moving target of scientific consensus and fact-finding and debate, and the cure for scientific mistakes is just more science, more testing, more data, more scrutiny, more criticism. And the process looks messy as we lurch about. We can leave aside for the moment. I want to come back to it, but there are obviously other problems like bad incentives and corruption and misinformation and fraud. There are possible contaminants to any human conversation and any scientific one. But even just the pure scientific process of criticism and uncertainty and further testing, that can look like an all too human failure to figure something out for the longest time. And I think people now just science as an institution, I'm just taking the temperature based on a few polls I've seen and just the general vibe on social media. It seems like the institution itself has lost some of its luster in the eyes of of non-scientists over the last few years, especially because of what's happened around public health messaging and COVID. I'm wondering what you think about that.
Yeah, I mean this is a very important issue, especially in modern times. So I think there are several moving parts here, and if I can unpack it just a little bit. So we live in a time where you don't have to get off your ass and go to a research library to gain access to research articles. You can get them online. But once you go online to find them, you have the mixture of what is authentic research with what people just want to be true, because any Google search will find you every other person who thinks exactly the way you do in what it is you're searching for. So you have a contamination, a noise level of your ability to find that which is authentic and that which isn't. That's the first part of it. Second part of it, the scientific community is not trained at communicating with the public. It is not it's not a part. I took one class in graduate school about giving public talks, something like that. It became a mandatory thing. I'm old enough, so I'm talking about the 1980s. So this was early. It was like, wow, why are you doing that when we should be learning what to do in the lab, right? So even that got pushed back in its day. So now you have people who spent their lives in a lab and they did well, and now they're promoted to some higher position of institutional authority and messaging, and now the press is in front of them. And so what are they going to say? All right, so we're early COVID, and one of them says, oh, this is not going to be too bad. We're going to have, it'll be over within a few weeks, and the cases will be contained. They don't know to say, well, they should have known, or in another world, they would say, based on these assumptions that we're making on how China is handling it and how Scandinavia is handling it, if we do the same as they do, we will contain this within 2 months. Okay? The if-then statement is so important. But the urge to give a definitive statement to the press so that the press can then create a headline is so high, it leaves you then susceptible to, like you said, the bleeding edge moving frontier of one research article versus the next, building on the previous one, possibly showing that it's not as effective as was intended. That's possible on the frontier. And so the couching of the advice, I think in retrospect, well, I knew it when it was happening, but institutionally, they had, especially the CDC, with their new director, said, we're going to have to be better at this communication. And that is for damn sure. So now you have this what is science and how and why does it work? You see people watching this edge of science move back and forth and give sometimes conflicting information. Now they want to apply that to anything else science says. They say, well, maybe Earth is not round, okay? Or maybe we're not warming the planet, or maybe because scientists can be wrong. And what they're missing is, of course, when you have a scientific result verified multiple ways by experiment, it is not later shown to be false. This is a missing piece of this understanding of how and why science works. It's not taught in the schools. It's not taught. And you even have people say, science, people who mean well say, science, unlike religion, will change its mind when the data shows that it needs to change its mind. E will never equal MC cubed, okay? It's MC squared. It's not, there are things that we're not changing our mind about, not because we're stubborn, but because the evidence is so overwhelming that we have something in the books that we're not looking to see if that's going to be different one day because all experiments have verified it. We're on to the next problem. So all of these are factors, and I'm pretty sure that if science were taught as an enterprise, taught as a means of querying nature, taught as a possibly unique way to sift that which is you want to be true from that which is true, then people would come out of the school systems without this kind of skepticism of the entire scientific enterprise.
Yeah, it seems to me that there is if not a paradox, something close to a paradox at the heart of the enterprise that understandably leaves people confused. And it's around this tension between valuing scientific consensus and scientific authority and not being blinkered by it. Because, obviously, almost by definition, scientific progress, any real breakthrough is a breakthrough because it goes against the grain of, received opinion and, by definition, expert, consensus, right? So it's when you have an Einstein who gives us special and general relativity, that goes against a prior paradigm. And, to the initial mystification and consternation and just frank resistance of many qualified experts. It even goes further with where someone like Einstein himself became resistant to quantum mechanics, right? And he famously said, God doesn't play dice with the universe, and debated Bohr until, I guess, the end of his days, never having fully come around. And the realistic picture of what's going on there is still not resolved. But there is this tension because you don't accept something as true just because most scientists believe it, or just because the most famous Nobel laureate in the given field believes it or says it's so. That's really not the cash value of the reasons for belief. To really get to the cash value, you have to actually understand the data and the argument and the evidence. And, it's in the math, it's in the detail that gives you the reasons for saying it's so, right? And so to take the simplest case, we believe that water is 2 parts hydrogen and 1 part oxygen, not because the most famous chemists have said so, but the fact that every chemist on Earth, who's neurologically intact, would agree that it is so. That is a surrogate for the real reasons to believe in the chemistry of water. And we can't. There's not enough time in a single human life to run every experiment and drill down to bedrock on every scientific claim. We have to take received opinion and scientific authority as a surrogate for our own investigation, all the areas where there's not a pressing reason to do otherwise. So there is this dual mode we're in because we do care about scientific consensus and authority. And when 95% of scientists say that something is so, the weight of our credence is with them as opposed to the crankish fringe who's saying the opposite. And yet it's also true that the lone voice in the scientific wilderness is occasionally right and can completely upend the scientific consensus based on better arguments and better evidence. And it's in the presence of any given minority voice, the one epidemiologist who says that, these new mRNA vaccines are going to kill millions of people, unless you really understand the field, or sometimes even if you do understand the field, it might not be immediately obvious if you're in the presence of a crank or a lone genius, right? And there's work to do to figure that out. And I feel like what we're living through now is an instance where trust in scientific authority and consensus has been dialed way down, right? The institutions, and for understandable reasons and for obviously spurious ones. The institutions have also heaped shame upon their heads by being, obviously politicized on various points, in debates about, gender and race. And there's just been some crazy stuff happening even in our best scientific journals. And you've got epidemiologists by the thousands castigating right-wing people for their public demonstrations, but then supporting left-wing people for their public demonstrations, all within the same pandemic. And so people have grown quite cynical. But I'm just wondering if you can speak to this core tension between trusting scientific authority and the progress of science being more or less synonymous with overturning authority, at least on certain points.
Yeah, so there's a caricature of science which has understandable and obvious origins, but doesn't represent the typical scientific advance. The caricature is everyone believes one thing, and then there's some lone genius who comes up with an alternative idea that would negate or otherwise render wrong the prevailing view, and then they're suppressed, and then they finally rise up, and then it becomes the new paradigm.
Mm.
And that is not how most of this works. All right. So, for example, take the discovery of the double helix. We did not have a prior paradigm before the double helix. It's like we just didn't know.
Right.
Okay. It was,
Right.
we don't know how it is. We're looking. Up comes the double helix. Oh, that's a good one. That works. And arguably one of the greatest discoveries in science was not the act of overthrowing a previously held idea. So, and I just want to make it clear that most discoveries in science are of that nature,
Right.
not of the nature of overthrowing a previously held idea. That's my first point. Second, a previously held idea, you use the word consensus and authority often in those few moments. And I don't like the word authority because that implies you should do it because they have some position of power. And plus consensus, the way most people hear that word, it would be opinions, the gathering of opinions, and you look at what the majority opinion is. We also use that word in science, but not to reference opinions, which creates some of this disconnect, communication disconnect. We use it for what is the scientific consensus. And what that typically refers to is the research papers on this topic. What do they show? And the research paper is not a scientist's opinion. It is the scientist displaying data. And provided they're not themselves biased, like I said, there's always that risk, especially in the scientific fields that involve the measurement and the analysis of other human beings. They tend to be particularly susceptible to bias. That would include all the fields of psychology, anthropology, and perhaps the most biased period of any field ever would be like 19th century anthropologists creating the races of man and ranking them and judging them and making that the foundation of the science of eugenics, right? There's a whole thing. You have to look really carefully when people start ranking other people. What is their field? What is their motive? What are their funders and the like? In the physical sciences, which is a little more distant from the social sciences and the biological sciences, more distant from human beings, we're a little bit less susceptible to that. And so you look at what does the body of research show? We will call that a consensus, but it has nothing to do with their opinions. And I assert that if you have 97 research papers saying one thing because the data shows it, and one person says no, you should bet on the 99. You should bet on that consensus because that's how it goes. The one person that says, do you have data? Do you have what? Well, I don't think it's that way. Go check it out. You'll find out that they will cherry pick things to fit their needs or their beliefs or their worldview. And just because an entire scientific community does not agree with you, it doesn't mean you're correct. Okay. So and the point with Newton becoming Einstein, this is a fascinating chapter. Here's the towering achievements of classical physics. And we have Newtonian gravity and Newtonian motion. Oh my gosh, it's explaining everything. But then, wait a minute, there's some things it doesn't explain. Ooh, okay, well, there's Mercury's orbit and there's weirdnesses and we don't, and Einstein comes along. So I got this. And it introduces special relativity and general relativity, which is basically the modern version of motion and gravity. And they supplant Newton. They don't go back into Newton's world and say, your experiments that you did are wrong. No, they're still correct. What it did was draw a larger circle around the Newtonian physics. And it said, Newtonian physics is a special case of Einsteinian physics. You put low speeds and low gravity into Einstein's equations, they become Newton's gravity. So yes, it was a new worldview, and it took a lot of people to get used to it. Oh yes. But that did not mean the previous worldview was all of a sudden wrong in all the ways that it had been tested. We grew in our understanding of the world. And Einstein's resistance to quantum physics, this was his attitude towards it, but he contributed mightily to quantum physics. Some of the most important results came from him. He just didn't like the underlying foundations of what could be making it. Okay, but the experiments still did all the talking. And so Yeah, I mean, people like to talk about scientists fighting and arguing at any conference. That's what they're doing. But once it comes through the mill, the experimental mill, that's not what anybody's arguing about anymore. And so yeah, what do we do about our institutions? They need to communicate better. They need to communicate more honestly. They need to not use the word, these are the errors in my measurement. They don't know how people hear that. They say, oh, they made errors. No, these are the uncertainties in the measurement, and every measurement has uncertainties. That's not taught. Where do you get that? You sort of get it somewhere, maybe in one lab class in high school. That's it. When that's a fundamental feature of what it is to take data. And the next experiment needs to reduce those uncertainties so that you can have greater confidence in what's going on. And then you look at what all the science tells you. And it's what comes. This is why we have the National Academy of Sciences. They digest this information and present reports. There it is. And that's we're not trained to do that. And it's sad because we needed that at the moving cusp of COVID.
Yeah, I think let's take another pass over the same terrain, because I think I want to drag you back into the weeds here, because I think it's just a mess, and if we can straighten anything out, I think we should. So there's a few other things I'll put into play here. Well, one is just an analogy, which I think I have from you. It's like I have a vague memory of you having said this years ago. I think we were probably at one of those Salk Institute conferences, and correct me if I'm wrong, or maybe I'm right, and there'll be no way to know. You won't remember having said this, but I think the analogy, when something like, imagine science is like an apple. At the level of the skin of the apple, the front edge of it, there's this area of scientific controversy where we're pushing into the unknown. And yes, there's, the whole paradigm could swing in the balance, but as you move away from the skin, as you go into the meat of the apple and down to the core, most of it is no longer in play, right? And things are not going to be radically overturned. And it's so, for instance, to give a biological example, it is just not the case that we might wake up tomorrow and discover that DNA has nothing to do with biological inheritance, right? That's not the kind of Popperian falsification that may yet await us in science. I mean, there's just too much data to conserve. It would be an absolute miracle at this point if DNA had nothing to do with inheritance. And so that's not the place, that's not the part of the apple where big movements are going to occur. Does that capture your thinking, or do you recall ever saying that?
That's not my analogy, but I like it. Generally, when I speak of apples,
they're falling?
No, other than the Newton apple that did not hit him, that the Earth's atmosphere is to Earth as the skin of an apple is to an apple in terms of relative thicknesses. So just to put that in context for people who think we're at the bottom of some infinite ocean of air, it's actually quite thin. That's the only case I would have used an apple, but I'm in full agreement with that reference. For that reason, the term paradigm, as introduced and used in the way that Thomas Kuhn used it for the structure of scientific revolutions, is way overplayed, okay? Because a paradigm shift, as people think about it and use it, is every scientist is thinking this, but then some new data comes along and then everyone shifts over and then they think something different, leaving you with the impression that science is a construct of belief systems at any given moment. And the last time there was a paradigm shift of that kind was the Copernican revolution, where no one knew any of this, okay? But that predates the active engagement of scientific, of experimental science, where you're going to say, I have an idea, but let me test it. The testing an idea did not become a routine thing until at least the 1600s. And the Copernican revolution basically predates that, well, goes right up to Galileo. My point is, yes, we can call that a paradigm shift. No, I have no hesitation. But Newton to quantum physics, Newton to Einstein, is not a paradigm shift as much as it is a growth in our understanding of the world. Because nothing shifted, it just got bigger. And it's a very important difference here. So I don't think anything is so strongly held as to be a paradigm if there's insufficient data to support it. They're just people leaning towards one idea or another. I would hardly call it a paradigm.
Now, what do you do about the social problem, really? I mean, it's only an intellectual problem in that we don't always have enough time to drill down far enough and figure it out and do science on the clock to anyone's satisfaction. But what do you do with the problem that you can always find a PhD or an MD or, a collection of them who will take any position on anything, right? You can find PhDs who will say that, smoking doesn't cause lung cancer. And there actually was a documentary on some of these guys, and they were the same ones who then set up shop on other points of non-controversy. They moved from smoking to, I think, fire retardants in California and other topics. But I mean, this is something we witnessed during COVID. You had people who you can just always find someone to put on a podcast who has the right scientific credentials, seemingly, and yet is taking this position that is extreme and extremely deranging of the conversation about, what is plausible or what is worth paying attention to in any given moment. How do you recommend people assimilate that fact? Because it is, I just noticed, people who I could name who should be, connoisseurs of misinformation at this point get quite bewildered in the presence of many of these people. And again, this is the thing that makes this so bewildering is that in the presence of an emerging pandemic, there really was a lot to be uncertain about. And there were, in any given week, the facts weren't yet in. And as I said earlier, it was a moving target, and to some degree it still is. How do you deal with this as a consumer of information? How do you think about the public consequence of basically everyone being able to do their own research, and therefore everyone is able to land in the presence of someone who seems to have all the relevant scientific bona fides, and yet they're so outside the bounds of scientific consensus on any given point that they should be treated with extraordinary skepticism.
Yeah. So the 900-pound gorilla in what you said is the people who are selected to give this dissenting view are people whose dissenting views resonate with your politics, your religion, your culture, or your overall desires. So you're you're finding someone who will fulfill what you want to be true rather than what is true. So that's a first part of that. Another part is that I try to address this in the book, in the chapter on risk and reward. So what I do is I take certain risks and I recast it in another way, which is a formally equivalent risk, but makes you think about it a little differently. So, for example, for a while, the oft-quoted number was 97% of research papers show that humans are warming the Earth. And in the past 20 years, that percent has gotten higher. It's probably 99 or near 100%. But let's go back to when it was 97%, and that's when everyone was talking about it. It's when that first manifested. So I said, all right, let's say there's 100 engineers, and there's a bridge just brand new built across this river. And 97 engineers say, if you drive your car across that bridge, it will collapse. And 3 of them say, no, not a problem. Just go ahead and do it. In fact, it'll be safe for you and everyone who follows you. Like, would you drive your car across that bridge? Like, would you? And I'm thinking you probably won't. Even before you investigate, are there biases among the engineers? You would say, these are engineers, and I'm not an engineer, but I'm going to go with this consensus. So to say, I'm going to go with the 3% of the 100% of climate scientists who are saying, by the way, many of them were not even climate scientists, but they were scientists, to say that we're not warming the Earth, and that fits with my economic philosophies, that I'm hoping that when you see these numbers presented in these other ways, you might think a little differently about it. Take smoking, for example. The last numbers I saw, there's an 8% chance of dying from lung cancer if you're a chain smoker, okay? And somewhere around there. And of course, there are other higher percentages for other diseases, but let's take lung cancer for a moment. And then I say, all right, let's recast that. So next Tuesday, everyone who lights up a cigarette, okay, will be entered in this lottery so that the moment you light your cigarette and take your first puff, 8% of them, their head will explode and they'll fall over as a bloody, gutty mess on the street. Okay? And then everyone else, if that didn't happen to you, you can smoke the rest of your life. Are you going to take that chance? Are you going to risk that? And by the way, that's a cheaper solution than what reality would be, because then you die immediately and there isn't this health care that has to be sustained while you first get cancer and maybe we'll try to cure you and remove a lung and whatever else happens. So that would be a way cheaper solution in society if that were enacted. Of course, it's not. But so I spend a fair amount of pages recasting certain risk factors that people are interpreting in ways that they think doesn't apply to them. And so other than that exercise, I don't have a silver bullet here. But what I do know is that public illiteracy, innumeracy in statistics and probability are at the heart of so much of people's understanding of risk. And I'm not the only one who thinks about it. In Oxford, is it Oxford or Cambridge? There's a chair, an endowed chair called the Professor of the Public Understanding of Risk. Somebody said, this is important enough, we're going to make an entire endowed line, professor line, to address this. And so, yeah, people are making decisions that they think they've thought it through correctly, and in fact, they haven't.
Yeah, well, let's linger on the topic of climate change, because that is especially difficult to think about, because as you point out, the economic incentives, certainly the short-term ones, seem to point in the direction of not taking it seriously. And it suffers from many of the variables I've mentioned so far. I mean, there are obvious reasons why the general public has kind of lost sympathy with the consensus opinion, because it's been so highly politicized. It's, in certain cases, religion interacts unhelpfully with it. But now in recent years, we have this new face of climate activism, which seems to be teenagers with obvious anxiety disorders and or autism. I mean, the teenagers who need help have in some cases become the most prominent voices of climate activism. And in recent weeks, and maybe this has been going on for longer than that, but I've just noticed it probably about a month ago, you've got people who are gluing themselves to the most famous works of art in major museums, or throwing paint or soup on priceless pieces of art. And this is turning off the general public for obvious reasons. I can imagine your head has been settled on the topic of climate change for quite some time. Why has this been so difficult to take seriously as a problem?
Yeah, it's a mismatch of timescales, right?
Yeah.
We have an election cycle that runs on a 2-year, with 2 years worth of expiration dates, and then they get renewed. And, senators are 6 years, presidents are 4, possibly 8. If you want to talk about something on a 20-year timescale, how's that ever going to show up in your stump speech? How's that even going to, who's going to be listening to you? Oh, the very youngest of the generations who will inherit what it is you do. But even then, is that enough for you to get elected on? So there's a mismatch between our political system and our capacity to engage solutions for problems that operate on a timescale longer than the political timescale of the society that we built for it. So yeah, I mean, this is part of the problem. By the way, that kind of activism, I mean, this is, you tend to see that with younger people in any level, in any topic of activism, all right? I don't know that 60-year-old men and women throw soup on paintings. It's the young generation. The young generation protested the Vietnam War. It was not the older people, it was the younger people. So it's not a weird fact that we have a social cultural issue in need of progressive change. and the next generation is leading that. That does not, I'm not surprised by that. And soup on a painting, it got your attention, okay? It got people's attention. And so, I don't know what to say other than to say, well, one day we'll think about solving this. That's a recipe for disaster when it involves an existential risk. And by the way, again, I blame people's the fact that we're not taught probability and statistics in school. So let's take the bell curve for an example, okay? In my world, we call it a Gaussian curve because he sort of first laid out the fully expressed mathematical form of it. And what it says is most things that vary would be in the middle, and there are fewer and fewer things out on each extreme, okay? Fewer representations of whatever variable you're measuring. Okay, so now watch. They announce there's been a 1.2 degree increase in the temperature, in the average temperature of the world, Celsius increase. And this will be devastating. And you say to yourself, I have more than a 1 degree variation in the rooms of the home that I live in. All right?
Yeah.
Within the same room, I have a higher temperature variation than that. And then from day to day, from day to night. So you're telling me I'm worried about a 1 degree change in the temperature of the Earth? Well, okay. Okay. Because we're not talking about what's in the middle. The 1 degree shift in the average, yes, that bell curve shifts a little bit to the right. Okay, temperature increases to the right. You shift it a little bit, it looks almost the same. Except when you go on the tail. Now you slide off to that tail. A 1 degree shift in the middle has devastating consequences out on that tail. And that tail of the distribution is where all the action is that people are reacting to. With the intensity of the hurricanes and the once in a century flood zone that now floods every 10 years. The epic rainfalls. Right now it was 73 degrees out my window today in New York City. All right. And so, well, that's odd because it's November. Well, it's just a day. Okay, maybe. All right. But the tail of that distribution carries all manner of extreme weather with it. And now we're talking about 2 degrees by 2030, 2050, or I forgot the exact year. And we'll just see more and more of this happen. If people knew and understood the effects of the tail of a bell curve of data relative to what you see in the middle, maybe they'd react differently. I don't know. Everyone in their math classes, I will never need to know this for the rest of my life as they learn trig identities. And so, I think it's
that is
missing
definitely
in the
a pedagogical mistake that we don't teach probability and statistics to high school students routinely. We teach them trigonometry and calculus and if calculus, which arguably have much less application to problems of immense social concern.
So my one conspiracy theory in the book is that the reason why we don't teach probability and statistics is because money for education in practically every state is partially fed by lottery tickets.
Mm-hmm.
And so,
Sorry.
So if you taught probability statistics in the school, no one would play the lottery. And so
you have this story about the scientific convention in Vegas where the I think it was the MGM Grand made less money than it had ever made in history.
The American Physical Society, which is my physics peeps, back in 1986, they were going to hold their convention in San Diego, and there was a hotel snafu. And Vegas says, we'll take you. And the MGM Grand, back then the MGM Marina, I think it was called one of the biggest hotels.
If you'd like to continue listening to this conversation, you'll need to subscribe at samharris.org. Once you do, you'll get access to all full-length episodes of the Making Sense podcast, along with other subscriber-only content, including bonus episodes and AMAs, and the conversations I've been having on the Waking Up app. The Making Sense podcast is ad-free and relies entirely on listener support, and you can subscribe now at samharris.org.